Hi everyone, my name is Naga Amruth, and today I'm going to talk about analyzing the evolution of robotics, a comprehensive statistical report. So, we are going to dive into the history, uses, development, and different sectors and how they developed using different types of graphs and charts. So, first thing, introduction. Welcome to the Evolution of Robotics Statistical Report. This presentation will provide a comprehensive analysis of the growth and impact of robotics in various industries. Now, first thing, before going into the statistics of robotics, we'll just get into the historical overview. The history of robotics dates back to ancient civilization, which is more than 18th century, laid the foundation for modern robotics. It was more than 300 years ago that the robotics started. So, the rise of robotics and artificial intelligence. So this is a whole big tree map, like a route map of how the robotics develop. First, we are going to know the three laws of robotics. Three laws of robotics were coined in 1941 by a scientist called Isaac Asimov. He says that first law, a robot may not inquire a human being. Second law, a robot must obey orders. Third law, a robot must protect its own existence. It means that it should not ask a human being to do a work, and it must always do the work exactly as human has said. In the same way, it has to protect its surroundings and its existence. So first thing, in 1921, first term as a robot, it was coined. And in 1931 and 1939, Electro, a humanoid robot, debuted at the World's Fair smoking cigarettes and blowing up balloons. So he was doing that work. In the same way, in 1948, another robot, in 1950, another robot called Alan Turing published paper about the possibility of machines that time, like an idea about how a robot, like an industrial robot, can use and then work in a real life. Then coming into 1950s, IBM 306, the first hard disk drive of 5 MB was introduced. In 1970, IBM 1330 100 MB per pack hard drive was introduced. In 1985, IBM D666, a 5.25-inch disk with 20 to 40 MB storage was introduced. So, this is like a whole timeline. In 1959, SMAMO was a robot installed, and then 1961, Ultimate robot called GM was installed, and then 1960, Mark I Perception was introduced. In 1968, a mobile robot called Shaki is introduced. 1972, a Stanford researcher developed a robot called Parry. A Parry, it actually designs and simulates a uh, paranoid phobia. In 1974, Intel produced its second generation CPU, that is 8080 chips, for the purpose of development of robots. In 1979, SCARA, an articulated robot arm. So robot arm will be like this and it works all the tasks. You can see here. And then in 1984, there was one more scientist called Doug Lenart and his team started to work on a robot called Psych to codify millions of pieces of knowledge and compose human communication. In 1984, the R85X was developed by General Robotics Corporation, including software. In 1985, Jordan Lanier's VIPL research has developed one more phase of robotics called Lanier Coink. In 1986, the most famous and popular company Honda creates the E-Naught, the first of a series humanoid robots that walk with 2 feet. Then in 1988, the first help-made service robot. What is a service robot? Service robot is used in multiple different industries to help the humans to bring all the items and then give it to us to make the work easy. So, like this, all the different types of technologies evolved. So, now let's dive deep into the top 10 robotic trends and innovations in 2024. So, robotics. There are so many different domains in robotics, like autonomous mobile robots, drones, intelligent robotics, Internet of robotic things, cobots, humanoid robots, robots as a service, automated guided vehicles, robotic security, assistant robots. So now there are different companies and startups involved in doing these kind of technologies to us. So this was a brief introduction about how robotics and how robotics is involved in this world and how different types of innovations are included in this world. So this is a tree map. What is a tree map? A rectangular boxes tree map is a data visualization technique that displays hierarchical structures using nested rectangles. Each box represents a specific data points or categories with the size of the box related to a quantitative value such as sales revenue, population. The larger the rectangle, the greater the value. So if the rectangle is small, it represents a small amount of value that it holds. In the same way, if it is very big, then it holds more amount of data, allowing for a visual comparison of properties and relationships between different categories and segments within the dataset. So here you can see 23% of the rectangle is occupied by autonomous mobile robots, 20% for cobots, 6% for robotic cybersecurity, 5% for drones, 20% for intelligent robots, and robotics as a service 16%, Internet of Robotic Things 4%, automated guided vehicles 2%, humanoid robots 2%, assistive robots 2%. So this is about the tree map. Then now let's see the supply chain with highest outsourcing. What kind of technologies which is related to robotics is giving a high amount of income? Like data analysis is giving you 41%, and then IoT is becoming 39%, and then cloud computing 39%, info security 31. Similarly, predictive analysis 29%, apps 25%, 3D printing 22%, robotics 22%, drones 20%, mobile production units 19%. These are all bar graphs with a percentage at the top and the type of quantity at the bottom. So these technologies are becoming a priority in the supply chain industry. And now let's talk about the distribution and logistics part. The 42% of the market is highly outsourcing for distribution, and the manufacturing, 37% of the manufacturing is outsourced, and finishing is 29% outsourced, packaging is 23% outsourced. Extent of supply chain visibility among organizations. So what is extent of visibility? So if a product or a technology is developed into the industry, how well it is reached to the customers or to the industry, that is called the extent of visibility. So limited visibility is almost like 62%. Extended visibility is very less, that is 17%. Visibility is only on production is 15%. So you can see this technology is very small and very rare for people to understand, and it's not that popular among everyone. So coming to the next slide, before going to the next slide, we need to know a definition about a type of map that is called heat map or a heat chart. What is a heat map? Heat map represented on a world map represented data variations or intensity through color gradients, showcasing geographical areas based on the density or magnitude of a specific parameter such as population density, temperature, or economic indicators. So this definition is used in the next slide. So this is the heat map, global startup heat map robotics. So what does it mean? What all companies involved at which geographical locations? So it means that suppose here in United States, California, Silicon Valley is a very big dark orange color, reddish orange color circle. It means that in this area, robotics startups are too much traffic. There's too much crowd of startup companies at this area. In the same way, you can see in Sweden and Ireland and in Denmark and also in Germany, you can see a very big circle here. Okay, so these circles indicate the extent of robotic startup companies present in that area. You can see that here in India, near Karnataka, Bangalore, there is also one average sized yellowish circle. It means that there are startup companies, but it is not that big as compared to the USA and Europe. And you can also see there are so many other places in the whole world, and it is actually denoted with a very small, minute circles and also in the lighter shades of yellow. So it means that it are very minute uses of robotics in that area. So this global startup heat map shows the geographical distribution of more than 8,949 startups and emerging companies we analyzed for this topic. It is the data which have been taken from August 20th of 2023. So next, coming to the annual installations of World Industrial Robotics. What are industrial robots? Industrial robots are the robots which are used in the manufacturing process and also in assembly lines and to make something which cannot be done by humans. For example, precision cutting, like CNC, you can say CNC. What is CNC? Computer numerical control. So these kind of cuttings cannot be done by humans on their own. So we require the help of robots. So that such kind of robots are called as industrial robots. So this is a vertical bar chart. What is a vertical bar chart? It has bars which represent the extent or the quantity, and in the x-axis it displays a type, like it can be a name, it can be year, it can be timeline, it can be anything. So here we have taken a time, years, 2011, 2012, 13, similarly till 2022. So here we can see that in 2011 there were 116 into 1000 units. What is the scale? The scale is to the 1000 units. So 1,66,000 units were installed in 2011. Similarly, if we see here in 2016, there were 3,04,000 units were installed. What we should do, we need to multiply the number with 1000. So we will get the total value of units installed in that particular year. Highest was in 2021. 2021 is 517 into 1000 is like 5,17,000 units were installed. So basically, in the whole graph, you can see it is gradually increasing till 2018, and after that, 2019 and 2020 is stable and a decrease because of COVID-19. There is a decrease in the annual installations of the industrial robots, and after that, the graph again increased in 2021. By representing the data in this kind of way, we can understand how and how to what extent the data has been increased, like the particular technology has been increased or decreased. So we'll get to know about the overall. So next we'll come to the annual installation of industrial robotics by country. So there are 15 countries which are actually booming in this industry. So first is China. As we usually know, all the electronic components and robotics materials, hardware, all is imported by China. So China holds the biggest market value. It is around 390.3 into thousands of units. So like 3,90,300 units. So it has the highest market share. Then comes Japan, then comes United States, representation of Korea, Germany. So Germany comes in fifth position. It holds almost 25.6% of the market value, like 25.6 into thousands of units. So in the x-axis they have mentioned the number of units in thousands, and in the y-axis they have mentioned different like the names, like as I said in the previous chart, in the previous slide, it has represented names of the countries, so it will give you an overall look of the installations. Now next come to the next topic, that is global autonomous robot market. What is a global autonomous robot market? We'll just understand what is an autonomous robot. Autonomous robot is a robot which will work on its own without any interference of a human. So we are actually giving a set of code to it or a program to run, and it will carry on that for a long period of time without any interference or without any disturbance. It has AI attached to it so that it can understand things and it can do it by yourself. So this is a graph. It is called as vertical stacked bar graph. There are different types of bar graph. In that, it is vertical stacked bar graph. What is a vertical stacked bar graph? A stacked vertical bar graph is a visual representation of data using vertical bars where segments of each bar represent subgroups or categories of that data. So these bars has like a different subgroups. In that subgroups, each subgroups represent a different value. For example, here we have separated the different categories by colors. Light blue is North America, orange is Europe, gray is Asia Pacific, yellow is South America, and blue is Middle East. So the x-axis shows the country, x-axis shows the years. So like in 2023, the expected, this is an expected graph, so it is not a past graph, it is about a future expectations. So in 2023, there was this particular amount of part in North America and this particular amount of part in Europe. And in the same way, it is going to increase over a period of time in this 1 decade. So from 2023 to 2030, the expectation is about to reach one uh, uh, 11,607 million US dollars by 2030. So can we even imagine this market is going to hit 11,607 million US dollars by 2030? So this is an expected data. It may be above it, it may be below it. That's just a prediction. So next, we are going to come to the service robots for professional use by application. As I have already explained in the second slide about what is a service robot, I will just directly go into the graph part. So this is a combination chart. What is a combination chart? It's a combination chart of a graphical representation that combines different types of charts, which includes like a single display, like a bar graph, a line graph, area graph, a pie chart. So different types of graphs are included to represent a group of data into one chart. So for example, in this representation, we have taken a bar graph and also it's not actually a bar chart, it is a histogram. Histogram separated by spaces, and then a line chart is connected to it. What does it represent? So in the x-axis, we have the names. What is that? Logistic robots, robots for public environments, professional cleaning, medical robots. So in these sectors, service robotics is used. And then in the y-axis, we have given the number of units. Okay, so number of units represent 0, 40,000, 80,000 to 1,20,000 and 1,60,000. Okay, so what are these color indicators? In 2019, it is represented by red. In 2020, it is represented by blue. In 2021, it's represented by gray. And what does this line chart represents? Line chart represents CAGR as a cumulative annual growth rate. It is represented in between the year 2020 and 23 in the form of a line chart. Logistic robots has a cumulative annual growth rate of those 3 years as 31%. Same way, robotics for public environments 39%, professional cleaning 41%, medical robots 30%. Next, this is overall view of a combination chart. Then we're going to talk about the global surgical robotics market. In this, we are using multiple different types of graph. Okay, so there we have a world map. Over it, they have represented different type of areas. So that means in North America, that market value is very high. Mexico is rest of the world. In South America, its market value is very low compared to other countries. In Europe, market value was again high. In Asia Pacific region, like in India, China, Japan, so that was in a medium quantity. Okay, so market by product. What kind of product holds what weightage? So services was holding a very less amount in 2020, and also uh, robotic systems is also average small in 2020. Among that, instruments and accessories was too high in 2020. Okay, so the expected graph will be too high in the year 2028. So market by application, we'll look into the market by application part. So here, uh, what kind of surgery, what kind of robot is used? Okay, so for gynecological surgery, I mean delivering babies, urological surgery, neural surgery, orthopedic surgery, general surgery, and other applications. So these are the types of robots used in these kind of surgeries. So highest was gynecological surgery. It is around 1,600. Okay, 1,600. And the highest market value it holded. Okay, so the graph is again decreasing. Why? Why? Because they have taken it in a not so chronological order. It doesn't mean that we have to arrange it in a decreasing or increasing order. This is a combination chart in the same way I was telling in the previous slide. Bar graph and then line graph. So these are the units and these are the names. Okay. So these are an overall view of global surgical robotics market. Then now let's talk about the autonomous mobile robots. What are autonomous mobile robots? As I already said in the previous slide, so these robots are equipped with AI sensors and advanced softwares, operate across various sectors like healthcare, hospitality, retail, and more. They assist in repetitive or dangerous duties. I mean, where in a chemical factory or in some welding factory or glass manufacturing factory where the temperature is too high, in that kind of places, if there is some faulty connections in the operating unit or the manufacturing unit where some machineries are faulty, in such kind of scenarios we can't go ourselves and check into the problem. So we need these kind of autonomous mobile robots which are equipped with these kind of sensors and wireless connectivity systems so that we can navigate it and go anywhere and then see where the faulty connection is or the faulty machine is, and then it identifies the problem and then it suggests us or the send some images from that particular part, and that will help us to change the machine or also repair the machine. In healthcare, like a patient care, as I said, time to time taking medicines to the patient's ward, and then it will also help in retails, for example, in supermarkets when you go sometimes. You don't have to search for the whole supermarkets to buy the groceries from. There will be a robot with its screen on its face and it will be having a tab, so you can just go through the tabs details and it will show what all the items are there and in which section you have, and then if you just select those items it will go there and then take all those items from that particular place and give it back to you. So these kind of robots are autonomous mobile robots. You doesn't need to have any human interaction at all. So these are all programmed and it is also using artificial intelligence. So the percentage of market, okay, share by end use in 2022. Okay, the total sales was the global market size. I mean the market size. It's not sales. It's the global market size is $2.9 billion in 2022. It is like share by end use. Okay, and that 77% holded manufacturing. So 77% of this part was all about manufacturing. Okay, so all these kind of autonomous mobile robots were used in manufacturing, and only a small percentage, like less than 25%, 23% of wholesale distribution was used, like the grocery thing or in the retail or in the medical sector of these robots. Okay, so mainly these robots are used in industries. Now, this is another example of a chart called Gantt chart. A Gantt chart is a type of a bar chart that illustrates a project schedule. It shows tasks or activities as horizontal bars along a timeline. Each bar represents a specific task, its start date, duration, and end date. Y-axis represents the lists or tasks, and the x-axis represents the time taken for completing that particular task. So there are three categories here: human in the lead, fast-paced robot in the lead, slow placed robot in the lead. So if we take our company as an example, like a process line, in that human beings, that is human lead. Okay, fast paced robot, the robot which works so fast, like a picking and placing thing or separating the items or like cutting the vegetables in an cold packing food industry or chopping the mutton and packing it into small pieces, and sometimes like a CNC thing, like fast it will move. So such kind of robots are called as fast paced robots. What are slow paced robots? Slow paced robots are like surveil robots. It will take a lot of time to walk around the in factory and check for the faulty connections and then fix it, and then It's like a slow-paced robot, SRL. We'll abbreviate it as HL, FRL, and SRL. So this, in the x-axis, we are representing the time taken, like 0, 10, 20 minutes, or 30 minutes, 40 minutes, 50 minutes, in the same way till 90 minutes, okay? It's like an average one day work, okay? Then the timeline for the three conditions is fixed to 90s, okay? Arrow denotes the dependency between an ending and a starting task. There is, there is an arrow that is connecting that rectangular boxes to the above chart, that is human. Human is represented in red line, robot is selected in the green line, and robot pick and place. As I said, picking and place is a fast paced robot, and then such kind of represented in light green color. So it is different for a different type of task. As you can see, it's self-explainable. And then uh, here in this image, you can see a person is actually fixing a part or like a setup of a manual assembly. He is doing some work in that is assembling the parts. So this is like a human in the lead example, and these are all robots. So continuing this topic, we will get into the most important graph. It's box and Whisker plot. It's also called as box plot. Displays data representation by the median, quartiles, and outliers in a data set. It shows the median as a line inside a box representing the quartile ranges, with whiskers indicating the minimum, maximum, and outliers, providing a summary of numerical data spread. For example, as I explained in the previous slide, HL means human lead, FRL means front fast-paced robot in the lead, and SRL represents slow-paced robot in the lead. So for completing a particular task, there are different types of requirements. Like uh, any particular robot you take, what is cognitive demand? Cognitive demand is intelligence required, the memory power required for completing that particular task. Physical demand is how much energy, torque, power required to complete the task. Temporal demand, how much patience does it have to do the work? And effort, how much amount of uh, time or energy does it take to complete that particular task? Frustration. Frustration is like a borderline. I mean, the deathline for that robot, where for example some robots after functioning for like so long, it goes numb, it goes glitch, and sometimes it stops functioning properly, doesn't give the data properly, it shows some big errors. So that is frustration point. And then performance. What is performance? Performance means uh in a period of time, like if you take, like if a robot has worked from morning 10 to night 10, like 12 hours, if you take average of each hours, that is performance. So all these have been represented in the form of a box plot. So here dotted lines represent maximum, and this is quartile 3. In between the line is median, and this side at the bottom is quartile 1, and this is minimum, and the upper is maximum. Okay, the dot represents mean. Mean is different, median is different. Median is the line here. Okay, here line you can see here. These line represents the median. First we have to find the median, and then put minimum, I mean the minimum and the maximum, and then we have to plot the graph. Then mean is different. It's calculated, and then we have to plot it after doing everything, and then we have to put the dot wherever the mean is. Okay, this is for different categories. They have represented different box and Vixen plot. So technological advancement, we are coming into the finishing part. Okay, the advancement in robotics have been driven by innovation in AI, sensors, and actuators. These technologies have enabled robots to perform complex tasks with precision and efficiency. Here you can see the image. So this is a robot developed by a company called Boston Dynamics. This robot's name is Scott. Scott does multiple tasks in multiple industries. For example, in chemical industries, in manufacturing industries. It will survey all the things, as I said, survey robots, autonomous mobile robots. So it has a similar structure and frame like a dog, so that it can walk, it can sense, it can smell, it can recognize things around it, and then it has cameras from all sides, so it will view the project, and it will capture the images and videos of that particular part, and it can be remotely operated from anywhere. So okay, this is an example. And then industry applications. So this is, you can see, this is an industrial robot. So industrial robot. Robot has well used in manufacturing, healthcare, space exploration, and agriculture. What are the challenges and opportunities? While robotics offers immense potential, challenges as ethical considerations, job displacement, and security risks must be addressed. However, the opportunities for innovation and efficiency are too vast. Like, because of robots, many people are afraid of losing their manual jobs, but it doesn't matter on a long run. Before, when computers were introduced, everybody said jobs will go, jobs will go. But now, because of computers only, there are so many jobs. In the same way, robotics will offer immense potential only if we know how to utilize that technology. In conclusion, the evolution of robotics has significantly imparted and impacted various industries. As technology continues to advance, the role of robotics will continue to expand, offering new opportunities and challenges. As we said, and as we predicted, the timeline for the graph is always increasing and never decreasing. Only in the 2019 and 2020, the technology of robotics has stopped because of the COVID-19. But it was stable, it did not decrease also. But it will pick up the pace from this year till 2030. It will reach its maximum potential by the end of 2040. And then there will be a stagnating pace. So these are the predictions which AI has done and given to us. Okay. So it was an overall conclusion. So here it comes to the end of the presentation, and thank you for giving me this opportunity to speak about this topic in a very elaborative manner. Okay, my name is Naga Amruth, and my roll number is 23 RVIGCP 27. Thank you. If you have any queries about my project, or if you want to know how I collected this data, it was mainly from research papers published by MIT researchers, Carnegie Mellon University, and then Stanford University. Those researchers' papers I collected, and these graphs I made it, and some I directly collected from Google and pasted it here, and some data I collected on my own and used the help of ChatGPT. And for making the presentation, I used SlidesGo. So these are all the sources which I used. So thank you for watching, and goodbye.